All right, let's talk about a number so big it almost doesn't make sense. I want you to forget what you think you know about the size of the global economy. Today, we're diving into a plan that centers around $100 trillion. And according to the source material, this isn't some fantasy. It's a roadmap for building an entirely new economy, not here on Earth, but out in space.
This quote right here, this is the key to the entire vision. The idea is that the next big economic boom won't come from just making things here on Earth a little better. No, it's about creating a completely separate, parallel economy in space, run by AI and built by robots. I mean, just try to imagine that for a second.
Just look at that number, $100 trillion. Let that sink in. To be clear, that's not just a ton of money, it's roughly the value of everything produced by every single person on this planet in a whole year. The ambition isn't just to build a huge company, it's to build an economic machine as valuable as planet Earth itself. The scale is literally out of this world.
So that leads to the obvious question. How? I mean, really, how on earth is that even possible? It sounds like something straight out of science fiction. But the plan to get there? Well, it doesn't actually start with some futuristic dream. It starts with a very real and very, very big problem that we're about to face right here at home.
You see, this whole $100 trillion idea isn't just about growth for the sake of growth. It's actually being pitched as the solution to a problem so massive, it could stop the AI revolution dead in its tracks. A problem that's tied to the physical limitations of our own planet.
And that problem has a name, the AI compute bottleneck. Think of it like this. AI is like an incredibly hungry beast, and it only eats two things, electricity and computing power. The thing is, as AI gets smarter, its appetite is growing exponentially. We're getting dangerously close to a point where our planet just can't feed it anymore.
And to really get a sense of the scale of this power problem, right now a giant in the field like NVIDIA uses around 10 gigawatts of power for its AI. That is a huge amount of electricity. But the starting point for this new space plan, 100 gigawatts. 10 times more. And that's just to get the thing off the ground. So you might be thinking, well, why not just build more power plants and data centers here? The problem is we'd eventually hit a wall, a hard physical wall. The energy requirements are just staggering. We'd have to mine unbelievable amounts of resources. And then there's cooling. These AI data centers run incredibly hot, and just keeping them from melting down here on Earth is a massive energy drain all on its own.
So if the problem is Earth itself, our gravity, our atmosphere, our limited resources, then the solution is, well, both simple and absolutely insane. You leave Earth behind. The whole idea is to move the entire infrastructure for AI into space, where the fundamental rules of physics and resources are completely different.
And this isn't some one-and-done mission. It's a full-on, step-by-step colonization of the solar system with computers. Step 1, a massive constellation of AI satellites in orbit, eventually scaling up to a terawatt of power. That's 1,000 gigawatts. Then Step 2, a base on the moon, which becomes a low-gravity launch pad to deploy a petawatt of compute. That's 1,000 terawatts. From there, the entire solar system becomes your toolbox for basically infinite expansion.
Okay, but to build this off-world economy, you're going to need a factory. And we're not talking about just any factory. You need one that can build the incredibly specialized computer chips that can survive and thrive in space. This is the Terafab, and it's basically the engine that would make this entire vision run.
And this is a classic high-stakes bet. The upside? Total control. You can design the perfect chip for the job, one that's hardened for space, and you don't have to rely on anyone. The risk? It's enormous. Building a cutting-edge chip factory is, without exaggeration, one of the hardest and most expensive engineering projects humanity has ever attempted.
And this quote right here really drives that point home. We're not just talking about another tough project. According to the source material, building this Terafab is seen as a bigger, tougher challenge than landing rockets from space or building the biggest rocket in human history. This is like the final boss of engineering.
So let's just recap for a second. We have a plan for a space-based AI network, built with custom chips from a one-of-a-kind, super advanced factory. How do you possibly manage all of that? Well, the analysis suggests there's really only one way. You bring it all under one roof with a gigantic corporate merger.
And when you look at this table, it just clicks. You see why a merger starts to feel inevitable. Each company holds a critical piece of the puzzle. Tesla has the world-class know-how in AI, robotics, and manufacturing at an insane scale. And SpaceX, well, they have the rockets to get it all up there. They're basically two halves of the same whole. And to pull off a vision this big, they need to be one company.
So what would that actually look like? Well, the proposed path is a series of massive, bold financial moves. First, SpaceX would go public, and it would likely become one of the most valuable companies on the planet overnight. Then, using that colossal market value, it would actually acquire Tesla. It's an incredibly audacious move, but it would create a single company with resources we've never seen before.
And this is so important to understand. This isn't just about combining two giant companies to make one even bigger giant. The idea is that together, Tesla and SpaceX can create a future that neither one could possibly build on its own. The goal is to create a single, unified entity capable of building that $100 trillion economy in space.
So when you put all these pieces together, the space-based AI, the robots, the moon base, the Terafab, you start to realize this isn't just about building a new company. We are talking about kicking off an entirely new industrial revolution.
This quote from the source material really puts things into perspective. This plan is being framed as something bigger than the railroads, the electrical grid, and the telephone network combined. We're talking about a fundamental change in how our economy even works, on a scale that is just mind-boggling. Now, an industrial revolution requires an almost unimaginable amount of money. Just for some context, one of the world's biggest chip makers is spending $400 billion on a new factory complex. And that's just to build chips here on Earth. The investment needed to build an entire economy in space is, well, it's on another level entirely.
So, with these absolutely staggering costs and complexities, you have to ask, how is this even possible? Well, the secret weapon might be using AI to build the AI. The idea is to use advanced AI tools to help design the factories, create more efficient chips, and streamline the whole process from start to finish. You'd be using the very technology you're building to make the building process faster, cheaper, and maybe, just maybe, possible.
So when all is said and done, what are we really looking at here? Is this the actual blueprint for the next phase of human civilization, a true off-world economy? Or is it the single biggest, riskiest bet in the history of business? You know, maybe it's both. The only thing that's for sure is that the next decade is going to be incredibly interesting to watch.